Hello everyone, welcome to my channel. Today we're gonna discuss the question appeared in the last bi-weekly contest, the third question, which is 2,467 most profitable paths in a tree. Yet the question is given undirected tree in terms of array of edges, and then yet describe a situation such that the Alice start with node 0 and Bob start with a random node, and then Bob walk to the node 0 while Alice walk to another node that is that is a leaf node. And while in this path, we need to simulate a sort of process such that if Alice and Bob both each move to an adjacent node, then they split the profit. If Alice or Bob visited a node that already been visited by the opponent, then they do not collect any profit. If the node is not being visited, then they just collect the profit, and the profit can be positive and it also can be negative, but whatever, you have to collect it. That is sort of a simulation. This process, there's no it's because it's not something like you can choose to give up profit or like to choose up something. Then you actually don't have a choice here. You just need to simulate this process. So that's like the first key observation for this question, I believe. And then the second thing is it giving you the edge in array of edge format, which probably not that we intended because it's not very good efficient for perform like a popular algorithm such as BFS, DFS, topological sort, edge stuff. So for this problem, there is another key observation is that it just a either depth first search or breadth first search kind of problem. So why I say that is because from the graph it says that it's undirect graph. That's the first thing, and it's undirect tree graph. What that means is that there's no cycle inside of this graph. So we can actually do the depth first search pretty efficiently. It's kind of like a general tree structure, I would say. So it starts from node 0 and then it just explores the node around the path. And we just need to simulate all those situations. And how many situations there is to simulate this process, I would say like to simulate this process, we maximally need to visit our node. That's it. And that's for Alice. And for Bob, it starts with a random node and it won't walk back to 0. And if we think about it twice, it's undirected tree graph, right? If it's undirected tree graph, then you only have one path from a node to another node. And I think from here, it says clearly rooted at node 0. So node 0 is a root. So there's always a path between those two. And there is only one path. There's no cycle in this graph. And yeah, and basically what we do, so we do is simulate this for the Bob. But this is like doing like something like doing depth first arch simultaneously. We do depth first search for Alice and we do depth first search for Bob. And for Bob, there's only one path. For Alice, there might be multiple paths, but it actually doesn't really matter. What we can do is we can store while we do depth first search, we track the profit, and for this profit, we sort of like we just simulate this process for each individual path. As like we discussed above, there's only like that many possible situations. We don't have to worry about time complexity. And yeah, and that's kind of the idea. So actually, my first idea is topological sort, but actually not topological sort. I'm thinking too much, and what I did here is I create a validated array because I want to perform depth first search later, and we converted array to edge format into adjacency list format. Because why do we convert to adjacency list format instead of adjacency matrix? Because it's a sparse graph. It's a tree graph, just only 2 edges. So adjacency list, no, I'm not saying like just maximum 2 edges, but how to say, it's like in average, each node only have 2 edges. That's a key point to take. That's the key take here. So it's a sparse graph, and so we use adjacency list. And then we use a pass, and then we do get zero. Get zero is actually a depth first search, as we can see here. So by using get zero, then we get this we get a pass which stores a node between the Bob and zero, and then we just simulate the process. So here I'm perform BFF search. Why do I perform BFS search instead of DFS search? Because we at the same time also have to simulate Bob. So what happened here is like I'm trying to simulate like such that Bob make this move and Alice made this move, and then Bob made this move, Alice made this move, and lastly Bob made this move, but Alice in this time it will perform this move and this move at the same time, but like in the same timestamp wise, then the 3 operation was performed at the same time. I want to sort of achieve that, and in order to achieve that, I have to use brief first search. And that's basic idea. We use this queue, like I use this outside queue to store like the step in one timestamp, and using the queue to perform all those steps in the like sort of like the same precedence. And here the only thing I want to notice is that suppose that I is equal to path index. I is the node Alice visiting, and path index is the node the Bob is visiting. If it's the same, then just need to split the spell. Otherwise, we just simply add a profit, and we just insert into the queue. We do the simulation, and as I discussed above, the time complexity is okay. And at the last, we simulate Bob's move. This is our Alice move, and this is Bob's move. And yeah, we also like clear the path, so it not be counted twice. And last, you return the global max. And if you run code, and yeah, we can submit it. And it accepted. So let me see the time complexity for this question. Oh, it's not so great, but okay, I guess. Oh well, let's see how other people did this question. Yeah, they use depth first search. I guess like just one optimization I could make here is like relative global max equal to int min. I guess like there is one thing I could make here is like if global max is greater than, actually wait, I cannot because there's negative profit, so I think they use some like more efficient depth first search or bridge first search, but I'm not gonna bother to implement it. Such like this is a depth first search, but we can do it in bridge first search way. It would be better. Actually, I'm not sure. I wouldn't think like there was much difference between like depth first search and bridge first search, and here we're using bridge first search, so this part should be fun. But anyway, I guess that's today's video. I talked about how to solve this question, and my code is a bit messy, but you can see some logic, and yeah, thank you for watching. See you next time.